Okay, so this is going to be isoclines, and isoclines just means places where you have the same slope. So if you're thinking about, isosceles, you have two sides that are the same. Isoclines just implies the same slope. Okay, and so this says dy dx, it gives you the equation for the derivative, equals x minus 2y. Draw isoclines at dy dx equals all of these values, so we're going to be drawing a lot of lines on this, and the corresponding slope field. Okay, so let me show you what I mean by that. The very first one says to set the derivative essentially equal to 0. So this is my derivative, x minus 2y, and I'm going to set this equal to 0. It's going to be kind of hard to show the whole screen and be large enough. So you can't see it. Might help if you move closer because I have to write it kind of small. Okay, so what we're going to do is solve that equation for y. So what would you like me to do? I like it, and then? Okay, so y equals a half x. Okay, and what that means is anywhere along y equals a half x, there is a slope of 0. Okay, so what I want you to do is draw a line through y equals 1/2 x. So that would have a y-intercept of and a slope of. Okay, so you're going to go up 1 to the right 2 a couple of times. Up 1, right 2. We're also going to go down 1, left 2, down 1, left 2. Okay, and I want you to draw a line through that. Now, there is a problem on your test. This is essentially the bonus problem, but it doesn't matter which one you call bonus. They all count for points. So if you left one off, you could still get 100 out of, basically, is the way it ends up looking like. Okay, so what that means is anywhere along this, the slope is equal to 0. So what I want you to do now, this is going to be our isocline graph, and the one to the right is going to be the slope field graph. And so what I would do is basically along that same line, you're going to draw little slope field lines of 0. Okay, so I'm going to kind of mark for myself basically the same thing I had here. Up 1, right 2, and I'm going to have little slope lines of 0 all the way around that, or along that. Okay, now it's all the way, like you could follow the whole path. But it's kind of a fast way to do slope fields, okay? Because I could substitute in 0, 0 and into x minus 2y, and I would get 0 minus 2 times 0, okay? I could put in the point 2, 1. I would get 2 minus 2 times 1, which would be 0, okay? But what I'm doing is getting a whole lot of points at the same time. So anywhere along that line, the slope is equal to 0. Does that make sense? Okay, so the next one I'm going to find out is all the places where the slope is equal to a half. Okay, so set the derivative, which is x minus 2y, equal to a half, and we're going to solve that for y. So tell me what you would like me to do. All right, move the x over, would look like that. Yes, thank you. Shame on me. Okay, so then we'd have positive 1/2 x minus 1/4. Did I get all my signs right this time? All right, so what that means is anywhere along 1/2 x minus 1/4, I'm going to have a slope of what? Okay, so what I want you to do on this one is just draw a 1/2 x minus 1/4. So that's going to have a y-intercept of negative 1/4. Okay, and from there you're going up 1 over 2. So that's going to be a whole lot of fun. You're just going to stay kind of right below it. Up 1 over 2, up 1 over 2. So you're really just kind of right below where you were over here. Okay, because you have the same slope, you're just down 1/4 from where you were before. So after I noticed that, I'm doing a little better. Okay, so every one of those points is just down a fourth because we just had a vertical translation of that. My green is trying to fail me. Now, I don't think it hurts either if we write by this one. This was the isocline where m was 0. This is the isocline where m was a half. Oh, my green, I have to have another. Okay, so now what we want to do is draw little slope field lines of a half all the way around there. So this becomes a little bit intricate. When you do it, so we're starting, say, right there. We know that's a point. Okay, and from there we have a slope of a half. So if you think of it as up 1, right 2, it would be like connecting this and this, but you're not going to connect it. You're just going to put something that has that as a slope. So it should look like little mini, I'm probably pretty bad at it, but right along here it should just look like little tiny, down a fourth, but little slopes of a half. It doesn't have to be perfect. Probably half of y'all's will look better than mine. No, that's just usually true. Alright, we get to keep going. Next, we're going to do that for 1. So we're going to set the slope equal to 1. Alright, so we'd have negative 2y equals negative x plus 1. Divide through by negative 2. Looks like we're just shimmying down just a little bit, down another fourth. Okay. And so I'm going to draw that line, and I've got a y-intercept of half, negative 1/2, sorry, and basically it just needs to be parallel to the other two. So if I get off by a little bit, it's going to be a drastic case and make the dots bigger. Okay, so along that red one is where I had a slope of 1. And so then I'm going to go over here and try to do slopes of 1. So say at that point, I'd want to be up 1 over 1. So it'd be like that. So it should look a little steeper than your last one, but still basically a fourth under all of these. And this is where you start wishing you had a computer that drew it all for you. Sam, how's it going over there, buddy? You ready for the next one or no? Yes, wait, don't wait. Okay, you're actually going to be drawing all these little lines on your test, just FYI, okay? It is tedious, I gotcha. But it was also on one of the IB exams. So I did 1, let's do 2. X minus 2y equals 2. So we got negative x plus 2. What do you know? We're down to minus 1. Okay, so we're going to go for pink. Probably not my brightest idea, but pink right under red. I don't have a lot of color choices, to be honest with you. And we need that same slope. I don't know, I'm looking pretty good on keeping my slopes good. Which do you like better, isoclines or slope fields? Alright. Okay, so I need a slope of 2, so I'm getting a lot steeper here. So from this point, that would be 1 point, I'm going up to right 1, so it's going to be pretty steep. And I'm just going to go along underneath it. Let's see, I was actually a whole half underneath, but yes. The slope of the last one, the one I'm doing right now, 1. So this, all my little lines for this one were supposed to be slope 1. All the lines for this one, slope 2. So when you're doing slope field lines, so all of these, all my isoclines have a slope. Oh, sorry, this was supposed to be positive 1/2 again. I don't know why I kept trying to do that. So all of your isoclines have a slope of 1/2, but these are the different slopes that each of your, along the isoclines, all those little lines are going to have. Does that make sense? All right, how you doing? Okay, we did 0, 1. We got, did I write m equals 2 for this one? All right, you got 3 more. Ready for it? Say yes. All right, so now we're going to do equals 4. That ought to give me like some better excitement here. I really wish we'd started moving that 2y over, but no. Alright, so at least we've gone down a little bit now. We have -2, so we have a little bit of separation. Still going to be parallel, up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. So all along this, I mean, we can share back and forth the colored pencils. That would go both ways. Okay, so all along there, I want slopes of 4, so that's really, really steep. Okay? It's like what? So I'm going to put like little dots so I can kind of be along the right path. Up 1, right 2, up 1, right 2, down 1, left 2, down 1, left 2. Okay, so 4 is pretty darn steep. 1, 2, 3, 4, right 1. If I was to connect it, which I'm not going to, it would be that steep. So these are pretty darn steep.
If we were doing slope field on the test, would it be smart to like go like up 4 over 1 and then draw a line, or just kind of eyeball guess?
It has to be as good as this. So in other words, I always do it for the first line, and then I just kind of copy the shape of all my lines. I can't really stand to do it that many times, but I'll do it once to kind of get in the general. They don't expect these to be perfect. All right, we've only got 2 more of these to go. What color should I use? I'm going above there. No, well, sort of. We have to solve it also, and we're going to draw a curve through a couple of solutions. So it's all going to be good. Okay, so next I'm going to do, where am I at? -1. You're supposed to support me and be like, yeah, that's what you're on. Okay, so x minus 2y equals -1. I'm going up here to write it. I'm trying to leave room because I know I'm doing some other stuff over here. Alright, I'm pretty excited. I finally have a positive y-intercept. I'm going to go with red. Okay, and so this is going to be, when I draw it, they're going to have slopes of -1 over there. So a half. Up 1, over 2, up 1, 2. Down 1, 2, down 2. Good old isocline. that's an M. All along there I have a slope of -1. Finally, a negative slope. Alright, now they are going to notice if you put positive and it's supposed to be negative. Okay, so all along there you have little -1 slope field lines. Have one more. See, this will make you happy when you're doing it on your exam, because you'll be like, I'm getting points for this. That's when it feels good. Alright, I think I'm going to go for blue for the last one. Okay, so a slope of 1, or sorry, y-intercept of 1 over 2. And all along this line, you have a slope of -2. So it's kind of crowded, don't you think? Okay, so this is me showing down to right 1 so I can get the right angle on these. Alright, what do you think of our isoclines and slope field? It's a lot of little lines. You can see why people came up with isoclines, kind of, though. I mean, you can get a lot of slope field, a lot of bang for your buck out of the slope field lines.
Yes.
Okay.
How many marks would a slope field cost?
Oh, I don't remember.
Please tell me.
I'd have to look it up. Okay, but slope fields, normally on the IB test, they would ask you to do it at certain points, unless they were connecting it to an isocline like this. There is at least one isocline problem on your review guides. You can kind of see how they would do it, and it might show you how many marks on that. I just don't remember.
Do we have our exam class on Friday? Or?
Yeah, it's coming your way fast, so you. I think so. Yes.
The week after, and the next week, since we are done with our exam, we should watch it.
Okay.
Yeah, I'm looking.
Yeah, the guys that haven't seen it will not be cute.
Okay. Now, here is tricky. You ready for tricky? The next thing says draw the curve that passes through 0, 1 and the curve that passes through 0, -1. So if you'll remember, I told you with a slope field, you could start at a certain point and try to follow the slope of the lines. You can also do that on an isocline. So what I'm going to do is I'm going to start at the point. Oh, this should say -2. That's going to cause me problems if I don't. So I'm going to start at the point 0, 1. I don't remember which one of these colors writes the best. Not the orange. Maybe the pink. I don't know what color you want me to try this in. I'm going to try that. Okay, so here's the thing. When you're right here at this point, what is the slope of the actual curve? -2. So the curve is coming in at a negative slope. when it crosses this isocline, what is its slope? And then, okay, so let's look at what happens. So you're kind of flattening out a little bit. -1 when you cross through there, 0 when you cross through here, and then you start to go to a slope of 1/2. So you start going up. Now, can you keep going up to get to 0? You can't really. Can you go down to get to a slope of 1? No. So you're actually stuck in between those two. And it looks like that. Stuck between the 0 and the 1/2. No. It looks like that. Yes. Exactly. Thank you. I knew there was a reason we sent you out English classes. Okay. Can you see that? I know it looks like a sea of lines, but it basically just went down and then it's stuck between 0 and 1/2. Now we got to go the other way. It says to draw a curve that passes through 0, -1. Jeez, I need like neon or something. It is going to get stuck somewhere too. I don't know. Y'all got any suggestions on colors? Okay. I like it. Okay, so we're going to start here at 0, -1. What is the slope at 0, -1? +2. All right, so here we go. We're going 2, and then we're going to get to a slope of, and then we're going to get to a slope of, okay, but can we get up to 1/2? If we're going from 1 to 1/2, what's happening to our slope? It's flattening out. Okay, so what happens is you actually get stuck under the 1/2. So one of them gets stuck over the 1/2, and the other one gets stuck under the 1/2.
Why would you get stuck under the 1/2? Why would you not just go to 0 and 0?
Well, you'd have to go down to get to a slope of 0. So, but you have to go up to cross 0. Does that make sense? It's kind of sneaky. Yes. Okay. So if you're at a slope of 1/2 and you want to go to a slope of 0, you're flattening out. Okay, which means that you're sort of, but you can't go up to do that. Okay. What do you mean your slope should be 1? Okay, so here your slope is 2, and then your slope is 1. Okay. So it went up to, it still went up to a slope of 1. I'm with you. And then it went to a slope of 1/2, but then it would have to keep going up to get to a slope of 0, and it can't. It's basically just, yeah, it could be right along it. Yes.
If its slope is like 1, and the slope of all those lines is 1/2, shouldn't it keep going up and reach the next line?
No,
It should reach at least 1/2.
it does reach 1/2.
It's like right below it. Yeah, it's just trapped right below it.
So it reaches 1/2 and then it stays right there, right? Never reaches. Alright.
Yeah, it's right
That's what
along
I
it.
thought, but like the way you made it sound like it just never gets to 1/2.
Well, it's right along it.
Wait, so does the line that passes through 0, 1 also flatten out above 1/2?
Yes. Okay. Now, the last thing it says to do is find the particular solution that travels through 0, 1. Okay, so it actually wants the equation of what you just drew a picture for. Okay, so what we have is this.
So on the test, what you have to do like the second part that we just did, like
Yep.
drawing the curve.
But I will say this one's probably slightly trickier. And also you're going to solve it, so once you solve it, you can graph it and also kind of know what it's supposed to look like. Okay, my question is, I've taught you a lot of ways to integrate. Thoughts on this one? Okay, what particularly makes you think integrating factor?
You can just move the 2y over and you got it.
Okay, and the y is to the 1. Okay, Okay, so that is a key part of that. So yeah, let's do that. Let's do dy dx plus 2y equals x. Okay, and then just to remember on your formula sheet, it tells you that it's supposed to be in this form. Okay, so I'll just kind of write that over here somewhere. It tells you it needs to be in this form, and it tells you that the integrating factor is e to the integral of p of x dx. Okay, and I think I can zoom in now because we're not looking at the slope field lines. Okay, so you've got it in this form. What is your p of x? Yeah, it's just whatever's in front of the y. So we need to figure out the integrating factor. So it would be e to the integral of 2. Think you can figure that out? I like it. Okay, once you have the integrating factor, what are you supposed to do? Okay, so I'm going to multiply both sides by the integrating factor. So I'm going to put e to the 2x on both sides and integrate. And it looks kind of scary. Except that on the left-hand side, it's just going to turn into what? So all of that whole left-hand side, it just turns into y times the integrating factor. And then over here, okay, so you're not stupid, but it is integration by parts. And how you tell is if you look, if u was 2x, all you would need is a 2, and you have an x you don't need. Okay, and so that's your clue that you need to do integration by parts. So that's on your formula sheet. Okay, so the integral of u dv is uv minus the integral of v du. Okay, so I need to figure out my u, and I need to figure out my dv. Thoughts? Your u is x because why? Yeah, it'll go down when you take the derivative, and then your dv is going to have to be e to the 2x dx. So the u is what you take the derivative of, so what do you get? Okay, and this guy you've got to integrate. So basically that's a u substitution. Okay, u would be 2x du. Do I have it? Can I get it? Okay, so I'd need a 2 and a 1/2. Is this too tiny for words, or what am I doing? Okay, so if you did that, it's basically 1/2 the integral of e to the u du, which is just 1/2 e to the 2x. You don't need the plus c. So then you have, the side stays the same, so uv, so that's this times this, minus the integral of v du. Yes.
I started to get a little confused when there were 2 u's and 2 d's.
Fair enough. I should have gone for w maybe. Would you like me to change it to w? How about w and dw? E to the w, dw. Basically, I was trying to, my dv was e to the 2x, and I needed to integrate it. Okay, and so that's basically a u substitution because this is like e to the u, and you need the derivative of the 2x to be here. So your w substitution could be that w is 2x, and so dw is 2 dx, and you don't have it, so you need it. So you put a 2 here and a 1/2 on the outside, and then it just looks like a 1/2 e to the w dw, which is just the integral of e to the u is e to the u, so the integral of e to the w is e to the w, and so that's e to the 2x. What do you think, Sam? It's okay? We're taping for you, Luke. Welcome back. Okay. Well, yes, but it feels sort of stupid not to finish. I mean, you know, in case he doesn't know what we were doing before or doesn't catch up to right where we were. Okay, so we have y e to the 2x equals a half x e to the 2x. I'm going to go ahead and take the half out. And this is basically the same substitution we had before. You want w's or u's? Because we don't have any more u's now.
We can do u's.
Okay, so u is 2x, du is 2 dx. Again, we don't have a 2, so we need to get it. So you have y e to the 2x equals a half x e to the 2x minus a fourth e to the u, which is just e to the 2x, plus c. I like it. I have been instructed to divide everything by e to the 2x because you normally solve for y. So I'm going to do that all the way through. Even your c. Don't forget your c. So you'd have a half x, these would cancel, minus a fourth, and I'm going to call this c e to the negative 2x. I'm just going to bring it up. And the last thing is we need to substitute in the point. It said find the particular solution that travels through 0, 1. Okay, so we go 0, 1. So we'd have 1 equals a half times 0 minus a fourth plus c e to the 0. So you have 1 equals negative 1/4 plus c. So c is 5/4. So you have a half x minus a fourth plus 5/4 e to the negative 2x. Why don't you graph that and see what it looks like? By the way, I only have 10 calculators that you're allowed to touch. Those are for biology at the exam over there. So you may have to share. I will have calculators for your exam, though.